Okay, welcome you all to the lab section. I have already shared the description. I will go through that now shortly. Before that, I thought I will explain you a few more things using Spider before we get into the exercises. Okay, I have to explain a couple of things before we start the lab. Let me first take a few things. Okay, now let me first summarize what we did last time. So what were we seeing today? Last class was to use NumPy to generate few data types. Okay, and then I explained how each data type differs from each other, how many bytes they occupy, using some built-in functions of NumPy. So all these data types are supported by dtype class, and we create a particular data type, maybe int or uint, c, something like that. Okay, we create u byte. We saw quite a lot of data types yesterday. To do the exercise today, we need to have two more data structures. That is, what is the string, how strings are constructed. There are two ways strings can be constructed, using some ASCII encoding, which is a 7-bit encoding, or Unicode. Unicode, as I mentioned, it has got different versions: UTF-8, 16, 32. The names signify that it is a 8-bit encoding. This is actually, it says UTF-16, but it involves two UTF-16 code, which actually takes around 21 bits to encode UTF-16. Okay, 21 bits. Now, what are these encoding? As I mentioned, for different languages, different fonts are there, characters are there. We need to encode them so that the computer, when we are displaying a character, it should know what is the format, what is the font it has to give. Suppose a character A has to be printed in a maybe take a 4x8 pixel grid, suppose like this. Sorry. If you want to write a on the pixel grid, you need to enable such a so many pixels to get a letter on screen. So this printing this particular font for a particular character is taken care of by the display driver, based on the display what you have, as well as the mapping of these pixels. If you have, whether you have chosen 760 by 890 whatever, or you have chosen a high definition screen, then based on the number of pixels there and then the font size you have, this A will be expanded like this or maybe printed like this. It could be anything, but the character A has a particular code which is only stored in the computer as a program or as a string when you are typing it. So that code can be ASCII if it is only you want to print only English letters. But if you want to print UTF-8 or so many other languages, the world has thousands of languages. So if you need to print all those characters, we need different coding. Encoding has to be done. That kind of wide number of encoding has to be done. So it has to be across the world uniform. Then only what you print as a French letter, a sentence, will be seen by everybody in the world as a French character. So there should be a common encoding for that. So that is how these standards have come up. UTF-8, 16 and 32, they are all evolved encoding. So that this ASCII 7 was not sufficient because it can only support 255 encoding. And in this also you have alphabets as well as other control characters like a carriage return, line feed, blank spaces, those things also need to be encoded in the ASCII. So what has happened is, on top of ASCII, the coding has started off adding more languages so that we can support universal encoding scheme, that even if any new languages come or new characters come, emojis, whatever you see, they all fall under this encoding business. So finally they are all to be encoded into some numbers, and it will be interpreted by the display driver to show it on the screen. Okay, so now to come back to our thing, we have in Python, we have a way of storing the string in either in terms of ASCII character, which will take only 1 byte per character, or if you follow a Unicode character encoding, then it has to take care of this 21 bit of encoding to be done on UTF-16 or UTF-32. Both are, what happened is, if you use UTF-32, it will take 32 bit of encoding, whereas if you use UTF-16, it needs 21 bits of encoding. But since all the registers of the CPU are all 32 bit wide, Python went with UTF-32 encoding, okay, for Unicode. And for a normal string, it will be a single byte encoding. Okay, so UTF-32 encoding means every character occupy 4 bytes of data. That much you should understand. So coming back to our definition, now we have np.dtype. So dtype is the built-in data type class. We want to create a string. Okay, now what is this S1? S1 is let me explain. There is a single character in this is called character code. Okay, instead of writing float, you can write F. Instead of writing string, you can write S. Instead of writing Unicode, you can write just U, capital U. So this is one character code to mention what type of encoding has to be done in building the string. Okay, so how many bytes you need for that. Now what I am trying to do here is, in this line, I am trying to define a definition. It's like a type def in C. Okay, type def. I'm defining a type, saying that I want to define a NP type. Okay, I have given some name to mention it, like this is a NP type of just a string, which means that it's ASCII string, a definition. Now definition using NumPy dtype. Dtype is a type. Okay, this is a type what I am trying to define, one character built using string ASCII character. This some name has to be given. Okay, ignore this particular thing, but to take care of the convention, I will tell you the reason why this is there later on. It will come. You will become clear. A dummy name, and then yes is the indication that I want to build ASCII characters. I want only 1 byte of data to be reserved for one string, one character. String is a string of characters. Okay, and this one means I want to reserve only 1 byte. I can say 2 bytes or 3 bytes or 4 bytes also. Then I will have that many bytes of characters I can store in this particular definition of this type. So in this type, I can only store 1 byte. So I am writing S, which is to mention that it is a ASCII encoding, and I need only 1 byte of ASCII encoding. So I am writing 1. Now I am just only defined a particular character type. I need to create now an array of things using this definition. It's like array of characters or array of float. I can have an array of this type. So, and while creating, I want to initialize it with zeros. Now what I am interested is only once I want to see that only how many bytes it occupies. So I want to create an array of 1 element. So 1, and then type, I want to use my own definition, not the NumPy definition. My own definition, what I have given, saying that it is taking 1 byte, length of 1. So this is also, definition also takes 1, and I want to create only 1 element of that type. That means I want 1 byte to be reserved for a NumPy element np cap. So if I just print it, I will say I will get it size as 1 because only one element is there. Item size, okay, item size, sorry, size is, I have not printed the size now. Item size only I have printed. Okay, so maybe I will say that item size so that you don't get confused with the size of array, or does it mean, so item size is 1. That means that one item in this array which is filled with 0 is having only 1 byte it occupies. And when I print the value, because it is a string, it's a null string, there is nothing to be, no, because I filled it with 0, it is nothing to print. 0 is having no valid encoding. So it is printing null string. Okay, only 1 byte is reserved, that's why it is showing B. Okay, now let me show you, if I need a Unicode type, what do I do? Okay, suppose I don't want a ASCII character, I want to use Unicode encoding, then what do I do? Same thing. Okay, the type, I am saying use string, I am having a string of Unicode characters. Okay, string of Unicode characters. That also I want only one Unicode. Okay, as I mentioned, it is a UTF-32 encoding, so it will occupy 4 bytes of data it needs, space it needs. Now for a change, I am filling it with ones. Okay, I can also fill it with zeros or ones. Then definition, I am saying this definition, you take this definition and make an array of one element. This I am giving only one element, so make an array of one element and fill it with 1. Okay, and I want to see how many characters it takes. Here also let us print it as item size. Now if you print it, it takes 4 bytes. As I mentioned, it is following a UTF-32 encoding. So for every character, even for printing 1, even though the encoding for this is occupying only 7 bits, lower 7 bits, because it's ASCII value, because ASCII values are mapped. Okay, all the ASCII values are retained in the UTF encoding also. Okay, remember that it is a superset. UTF-32 or whatever is a superset of ASCII. So it follows the same encoding of ASCII. So, but it occupies 4 bytes because it is following Unicode method. So it follows Unicode encoding. Now, if you see that it prints Unicode underscore here, whereas what I have given is a capital U here. This is the another way of informing the NumPy, saying that I want to follow a Unicode type. Okay, that's all. So I hope this is clear. Now our job is not done yet. This we have created string of either ASCII characters or a Unicode character, but now I am interested in, similar to a structure, I want to create a data type. Okay, this is a type def we use in C, sorry, capital type def we use, similar to type def with a different types, float, int, character, array. Okay, we want to have a multiple elements in a structure, similar to a structure in NumPy. Okay, we want to do it in NumPy. That is called structured data type. Okay, now structured data type, we can have our own definition. Okay, there is nothing called NumPy standard definition, because it is like this. Now structure is our own wish. What you want to put inside is our own wish, but what you put inside has to be one of the basic data types. Okay, it can be an array of basic data types also, or a single element also, but you can have a structure with the basic data types. Similar to that, I can have a definition called a structured data type with multiple basic data types that I explained to you so far. Okay, in the last class as well as today's class. String also can be a part of a structured data type. Now, how do we do this? Okay, that is what we need to see. I am going to show you that portion. Okay. Now let me take this also completely. I am copying all this because I have written some links as well as some comments which will be useful for you when you are reading through it on your own. So now let me explain this. Understand it, it looks little bit confusing, but once you have the hang of it, you will be able to define your own structures. Okay, here I am not defining a structure now. I am just showing you with a raw element how do I create a structured data type. Okay, after that I will say definition. Okay, so now I am trying to create an array with specific values. Now what are the values? I want to give an employee name as a string, and then I want to give the number of some number. Okay, it could be, this is age. Okay, I want to give a age of the employee. I don't know, it is I should not give 11, then it is illegal to, child labor is illegal, so let me not put 11 there. Okay, now it is illegal. So we have an employee with the age. What we do, if you want to create a structure, give the actual data that you want to initialize it with. This is one way of doing it. Okay, if you are creating a huge number of arrays, you cannot do that. But if you are just initializing only 2 or 3 elements, I can give the data also along with that. So right now I am showing you how to create a structured data type having multiple basic data types in it, and it is of type numpy, and I am creating an array of that type. Okay, now I have the employee name and then the age and then another. So now number of entries I give decide the size of the array. Since I have given only 2 tuples, I am indirectly saying that this particular array is going to have only 2 elements, and each of those elements are going to have 2 data types. One is of Unicode string. Okay, Unicode type string of length 10. If you remember earlier, I put 1 there. If you see, I put only 1. I thought I wanted only one small character to be stored there. Here I want 10 of them, 10 of Unicode characters. Now you can imagine I am reserving a 10 locations of 4 bytes each. Okay, for the name, one particular name. That means if I have 2 entries, I need 80 of them. Okay, fine. Now what is the age? Age is a next element, which is data I already given. What is the age? 22 and 33. That is a element. It's like a structure. Within the structure you have a element type in C. Similar to that, I am giving a name to a element inside a structure. Okay, now you will understand why I was using that kind of a definition there. So here I am saying age, as I mentioned, we don't need a huge space. So u byte, because unsigned it is going to be, age is not going to be negative. So I am happy to have, or I want only this much. Okay, 255. I'm not expecting the age to be more than 255. So I am happy to reserve one unsigned byte for the age element. So what I am supposed to do, I am supposed to give the number of elements as the actual data in a list. Okay, this is a Python. Okay, please remember this is all handled by the Python interpreter only. It is fed to the NumPy's library, but what is running all this is Python interpreter. So the definitions are correct and valid. It is all list element with tuples having 2 elements. One is a string and one is a some integer type, integer object. Okay, because it is in the Python world now. It is yet to create an NP array, and then I need to say what type they are, because Python, when it is passing it to a NumPy library, it has to say each of the element how much space I want to reserve. Right now, maybe employee name I have given only this much, but later on I may have to write a huge number of entries. So I should decide as a developer how many characters that I expect the name to have. In this case, I am thinking that only is not going to be 10. Okay, just for the computation purpose, I put 10. Okay, so I am saying the name entry maximum I can have 10 entries, 10 characters of Unicode encoding, and then age is of only byte, so I'm reserving only one byte. Then I am saying you create an array. Now it will create an array of type NumPy because it is internal to NumPy. So it will reserve based on the size what you are given. It will reserve a contiguous memory and then give the reference to that somehow out. Okay. So we get a contiguous memory reserved for the two entries of this. Now what I want to print it now. I want to say what is the type of that what I have returned, what I got, and then what is the size. Now this size says the array size. Okay, it doesn't show you because it is an array of elements. So number of entries it will give. Okay, and then strides I mentioned it already earlier. Okay, let me first print it before I explain to you so that you can have the value also here, so you understand better. Now this is the entry, this is the output we have got. So let us only look at this output. It is two entries we have created and it says 41. Let us understand this 41. Now let me take out this. Okay, now why is it 41? I don't know whether by now you might have computed it yourself. See, it is having an element called name of 10 element individual characters, and each character is of Unicode type, and I said that Unicode is following UTF-832, which is needing 4 bytes. So I need 10 elements of each of them taking 4 bytes of memory. So how many you need for this name element? We need 4 into 10 because I have given U10. Okay, U10 I have given. So it is 4 into 10, 40 bytes I need. Now what about the age? Age is a U byte. That's all, only 1 byte. So age is going to occupy only 1 byte. So 40 plus 1 is 41 bytes it is going to occupy. That's what you see as a stride. Why it is called stride? Because stride is something when you have an array of something. Now array of structure, this structure is nothing but NP Emp data. Okay, it is a type is NP Emp data. Is actually EmpData has a complete array. Okay, I am not definition I am not given, so it is a complete array. So but I have given each element here 1 and 2, so each of them are going to occupy 41 bytes each, and then 40 bytes are reserved for the string name string, and then 1 byte for the age. Okay, age, this is for name. So this is how the contiguous space is reserved. So this is very strict. It will not go beyond that many bytes. Okay, because finally this is going to be executed by the C code underneath in the NumPy library. They are okay to have a very compact contiguous memory structure so that it is occupying less space in the memory, as well as it will be faster when the C library is working on this array. So this is how it is stored internally. Okay, so what you see here, 81, 41 is a one particular element size. So you can easily say that stride is actually giving you the size of one element in the array, and 82 is double of that because I have given 2 entries here, and I am printing this data, employee name, age 22 and 33. Okay, I hope this is clear. Okay, is there any doubts on this? So because this has to be very clear to you, I hope no doubts on this. Then let me proceed further. Okay, now how do we create a structure type like what we did for our employee data? Okay, now let me open this. Okay, sorry, I want to print a few more data about the employee so that I will tell you how to access individual element so that you get a better idea of how to access the individual element in the NumPy array. So you know very well there are only two elements here. So I am accessing it as a 0 and 1. So the 0 should print, as I mentioned, this NP Emp data is a complete array what I have created, 82 bytes of array. I am accessing 0th element means it is going to print only this much of information, and then one first element, in fact it is second element, index Z1 is going to print that thing. And then if I want to modify now, okay, I have to take care that I don't exceed the 10 characters. How many are there now? I think it will accept it, maybe, I'm not sure, but let us maybe I will, we have to check it. I will do that. Okay, now I am just changing this element content to something, and what do? I am changing the 0th element and the name of the element. It's like a dictionary. Okay, you can access it as a dictionary. So 0th entry and name element in the 0th entry, I am changing the string, and then I am changing the age to 111 and then printing it again. Okay, and this is not needed, it's not relevant for this particular exercise, so let me print it. Now you see here the name is changed. Is it correct? Am I getting anything wrong? Okay. Oh, order is yeah, correct only. Yeah. So this is the last two entry printing. So I change the name and I am getting it here. Okay, 111333. So I hope this is clear to you. Okay. Now let us do the definition of what I mentioned it, what is required for our exercise today. Okay. Now this is the, I want number of employee to be a okay, before I go, let me explain what I want to do and then we'll come back here. Okay. I hope there are no questions so far. Okay, now let me explain what I want to do it in the class, in the lab today. Then you can start off with the implementation. So what I want to do is define an employee structure called Emp Data Def. Okay, with the following fields similar to type def in C. I want an ID, employee ID, which should be unique, ranging from 1 to 2 power 32. I hope now you understand. Okay, I should not say 2 power 32, then minus 1. Okay. Okay. Employee ID, I want maximum should be within this range. I'm okay if it is within the range, because I am not expecting my employees to be more than 4 to the power of 10 power 9 employees. The whole world has to work for me. So max ID is this much. Okay. Name, I want maximum 64 characters of single byte ASCII characters. I don't want to reserve Unicode because I am expecting only English names to be entered. So I'm happy to have ASCII characters used for the name field and maximum of 64 characters. I don't expect the name to be more than 64. Age for my company employees is 20 to 60. So beyond 60, they will be fired. So I'm okay, or not fired, retired. Height of the employees I want to capture, because my company job involves something to do with the height of the person. So it should not be like a airport, air hostess. We need some height definition they'll give. So 150 to 180 centimeters. I don't know really it is too within. You will find somebody human being with this height or more than this. I think I just gave some number. Okay, it's centimeter units. So these are the information I want to capture for every employee of the company. Now, I want you to be very careful in choosing the right data type, because you know that the employee size could be huge. So I don't want to waste my bytes in the data. not too many things more than what is required. And then I want to create an array of this type of length num employee. Okay, this is another definition. Nump employee, number of employees in the organization. So you can in fact modify it to see the performance of the implementation, Python implementation and NumPy implementation. So that's why I want to put a variable here. You use this variable only to define all the functions that you write, accessing the array, going through the array. Everything should be based on this variable name, variable value, because I may change it and your program should work for any number of employees in the organization. So you have to define one Python variable. Of course, it will be in integer, and it holds number of employees in your organization. You may be required to make it as huge as possible because it is not going to be a NumPy element. It is an integer object of Python. So you don't need to worry about the size or anything because it's only one entry. So no problem. Don't worry about optimizing this value. You have to optimize only the array because that is going to hold data of all the employees. But here I'm going to create one integer object to hold the total number of employees in the organization. So you can use the integer variable for that, Python integer variable. You need to write few functions assigning employee name. Okay, I will tell you what name to be assigned randomly, not randomly, some specific name. And the employee ID has to be unique starting from 1 to maximum, whatever is given. And then you need to write a Python function to assign the employee age. When you assign means you are assigning for the whole, all the entries. Okay, don't think that you are making an entry for one particular element in the array. For all the employees, you will create as many number of entries as the number of employees says, and then you will start calling these functions. You write it as a function, pass the array into them, and you should initialize all the entries that you have created for the employee. So age you have to enter. I will tell you what age to enter, and then employee height has to be entered, and then you have to write a function also to find the average of both age and the height. What is the average age of your employees, average age of the height of the employees in the organization. So these are the things you need to do. You need to write Python function as well as using NumPy. Okay, let us come to that now. Now, how do you define a structure? As I explained earlier, what we do, we are defining a structure type of NPD type. It's not an array, remember, it is a D type. I am giving a single list with all the elements that needs to go into the structure. Okay, I am having an element of ID. This is a name of the ID, that element in the structure ID. Another one is name, to hold the name of the employee. This is to hold the ID of the employee, and age of the employee and height of the employee. This is a one structure type. Now ID has to be of type uint. Okay, unsigned integer, because ID cannot be negative. I am expecting it to be 1 to 32. So uint will actually on this machine will give you a 32-bit value. So uint is fine. So np.uint. Name is the element's name, not the actual name of the employee. Is a element name of S type. S means it's a ASCII character, single byte characters. I want to reserve 64 because the requirement said that 64 is the maximum limit. So now the name maximum can go up to 64. So I want to reserve 64. Age is of U byte and height is of U byte, because the range I gave you can be accommodated within a U byte. Because 180 I gave you, if you put byte or a sign byte or a int 8 if you put, it will not be suitable because height can go up to 180. So U byte is very important. I have given you the things here itself. I want it to be 0 field, so you have to call it as np.zeros after creating the array of this type. Okay, how do you create? np zeros, number of employees, that many entries you want to create, and the type is of this type. So it will create number of employee, number of elements in an array of this type. That means it will reserve elements, all 4 elements it will reserve space for, and then it will fill it with 0 and return the structure to you. Okay, it's a byte contiguous byte space. Now what you should do is, using this array, you have to now fill the element. Okay, Python code you have to write, as well as using the NumPy function. I will tell you what function to use. Now fill in unique employee IDs from 1 to whatever number of employees, and then fill in the names of the employees as name 1, name 2, etc. Age, I want you to randomly choose between 20 to 60. Okay, that you can use the np function only, np random.randint. You can say what is the seed, starting seed, and then high value. It will generate within the limits. It's inclusive on both sides, so it will generate some random integers within the limit. Height is also you can generate like this, and then find average. You write a function find average. Now you need to write NumPy using the NumPy library also, which is np average. You need to pass the array of age. Okay, age elements only. Okay, it will internally, because it is a np array, this function knows how to access only the age elements within the array. So it will find the elements of age, all the edges of the employees, and then find the average and give you. Similarly, height. Now I want you to compare the time taken by both by using this import time and then time process time nanosecond. So it will return the value number of nanoseconds taken to get the timestamp of before and after the function is done, both for Python as well as for the NumPy libraries, and compare the values. Okay, this is what I want you to do. I hope this is clear. And then initially, how do you do it? 4 you create, and then 4 or 1 element, and then try to find out the average and verify yourself whether it is doing properly or not, and then add the performance metrics. Then initialize the employee with the 0 first, and then actual data, call the functions, and then do it for higher numbers and see the difference in the performance of Python as well as NumPy library. This is the job to be done. Now to make your life simpler, okay, typing will be difficult. What I will do, what I have developed today, the code, I will send it to you right now. Okay, I think you can cut and paste from this. It has got all the information. So this file I will send it to you so that you don't need to scramble typing. Okay, I am a very helpful guy. Okay, now what is this? I should not send you the solution that I have. This file I should not send you. I should send you only the Lab5a D types.